Hello guys, this is CodeNCode and this is video editorial for the problem minimum falling path sum taken from Leetcode dynamic programming. So the problem statement is really easy. You are given a square, a 2D grid of size n cross n, and we have to find the minimum falling path. Basically you have to start from any cell from the first row and you have to reach the last row, and you have to end your journey in the last row. In which cell doesn't matter. So you have to start from any cell in the first row, you have to last in any cell in the last row, and the cost of the path you choose must be minimum possible. Now, so if you see starting from this cell, you can reach the operation you can perform from any cell. Either you can do you can go down or down right, that is from here this cell, or sorry, down left. This is so from this cell either you can go down, down left, or down right. So these are three possible operations. Of course, for some cell down left or down right would not exist. So starting from here, one of the possible paths is go from here to here and then here. So the cost of this path is actually 8. Starting from here, you can go here, here, I mean down, 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 so you reach the last row. So end goal is to reach the last row, any cell, doesn't matter. So from here, starting from here, one of the possibility is to reach here or here or here. Now, in dynamic programming part 1 series, in lecture 12 I have already explained how to solve these kind of problem. So even though in this problem I'll be taking a small example and explaining you how to solve this problem, but for deep insights I would highly recommend you to go and watch those lectures first. Lecture 11 and lecture 12 in dynamic programming series part 1, both of them describe how some kind of path query on 2D grid is solved using dynamic programming. For this problem, what we'll do, we'll take a DP array of the same size as the input array. We'll initialize the last row same as the input array. You see, now we'll start filling each row one by one, starting from second last row. So we'll first fill this and then fill this. So first let's fill this this cell. For that, for this cell you have, for any cell you have 3 operation, but for this you have only 2. So we'll minimize. If from here we move down to here, the cost would be 8. If from here, from this cell we move down to here, because down right, so the cost is 9. So of course minimum of these two is 8 only, so you choose this cell to move on. So 8 plus the cost of this cell itself, so cost of this cell itself is 6. So 6 plus 8 is going to be 14. Now for this cell, either you can go down, left, or right. Minimum of all of these 3 is 2, so of course you would choose 2 to step on, and the cost of this cell itself is 5, so 5 plus 2 is going to be 7. For this cell, either you can go down or down left. Minimum of these 2 is 2, so of course 7 plus 2 is going to be 9. Similarly, for the we'll fill from here. So for this cell, minimum of these 2 is 7, so 7 plus 3 is going to be 10. For this cell, minimum of all these 3 is 7 again, so 7 plus 1 is going to be 8. For this cell, minimum of these 2 is 7 again, 7 plus 2 is going to be 9. So what this DP array tells you is that if you start from this cell, the cost to reach your end goal, that is to reach last row, is 10. If you start from this cell, the cost to reach your end goal is going to be 8. If you start from this cell, the cost to reach your end goal would be 9. And we have to print the minimum of these 3 because it doesn't matter which cell you start, but you must start from first row. So all of these cells lie in first row, so either you can start from here or here or here, but we see starting from here cost us 8, which is minimum, so this is going to be our answer. So how we solve this problem? This is a solution. We calculate the n and m, even though n and m are same in this, I guess, yeah, this is a square, so n and m are same, but doesn't matter. I've calculated n and m. the number of rows and number of columns. So we have taken the DP array of the same size as the input. Now we are filling the last row same as the input array, as I have already explained that we have done here. We started by filling the last row of the DP array as with same elements, the same input as the input array. After that, this is basically your initialization process. After that, starting from the second last row, we'll fill row by row and we'll fill each column. To do that, what we'll do, of course, we'll initialize dp of ij to be ar of ij, because the cost dp of ij will be the cost of the cell itself plus minimum of bottom, left or right. So we have initialized it with the cost of itself. Now we are calculating the minimum of 3 steps. So no matter what, your minimum or your down cell always exists. So we have initialized minimum with the down cell. If the down right exists, then minimize minimum with down right cell. If the down left exists, minimize mn with down left. After all of these operations, mn contains the minimum cost of down, down right or down left. If those cells exist, these if condition take care of that. After that, dp of ij will be added with this minimum. Finally, the result will be just initialized result with infinity, that is int max. After that, for each single cell in the first row, basically this, now we are getting the minimum of the first row. That will be our result. So for each single cell in the first row, we are minimizing the result and finally returning the result. So this is how you solve this problem, minimum falling path sum, from Leetcode. If you have any doubt or query, of course you can ask in the comment section. This was all for this lecture. Thank you guys for watching, and if you have any if you have any doubts or query, you can ask in the comment section. So till the next video drops, keep coding. Thank you.